Hello and welcome to this video from Excel Dev Studio. This is video number 3 of 6 from Introduction to Building Microsoft Excel Solutions with VSTO. VSTO stands for Visual Studio Tools for Office. With VSTO, we can build solutions to extend what Excel can already do. If you haven't done so already, please check out video number 1 and 2. Video number 1 gives a background on VSTO and compares it to other Excel development tools. Video 2 goes over Section 2, setting up your environment. Video 2 also discusses Section 3, the 2 different types of Excel solutions we can build. For this video, we will cover Section 4, the Excel object model. We will give a background on the main objects and how to use them with detailed examples. In this section, we discuss the Excel object model and how to use the main objects. The Excel object model is a set of objects we can use to control Excel. The primary objects are the application, workbook, worksheet, and range objects. These are the objects that we will mainly use when developing Excel solutions. The object model is organized in a hierarchy with the application object forming the root. From the application, we can access the other objects that make up the object model. The application object represents the Excel application itself. The application object exposes a great deal of information about the running application, the options applied to the instance, and the current user objects open within the instance. The workbook object represents a single workbook within the Excel application. The workbook is part of the workbooks collection. The worksheet object is a member of the worksheets collection. Many of the properties, methods, and events of the worksheet are identical or similar to members provided by the application or workbook objects. The range object is the object we will use the most within an Excel application. Before we can manipulate any region within Excel, we must first express it as a range object and work with its methods and properties of that range. A range object represents a cell, a row, a column, a selection of cells that contains one or more blocks of cells, which might or might not be contiguous, or even a group of cells on multiple sheets. Before getting into some examples, let's understand the assemblies that are used to build Excel solutions. First, we have unmanaged assemblies that are used to talk to the Excel object model from .NET. When we are talking to an Office object model in .NET, we are talking to it through a .NET technology called COM interop. The Excel and other Office object models are all written in unmanaged code such as C and C++. To talk to these COM interfaces, we need a .NET wrapper to interoperate with the unmanaged COM interfaces of Office. This wrapper is called the Office Primary Interoperability Assemblies, or PS. There is a PF for Excel and one for each of the other Office applications, such as Word and Outlook. The namespace for the Excel PA is Microsoft.Office.interop.excel. Second, we have the managed assemblies. The managed assemblies for VSTO implement the properties, methods, and events defined by the PS. The namespace for the Excel VSTO extension assembly is Microsoft.Office.Tools.excel. There are similar ones for other VSTO Office applications. Luckily, when we create an Excel document level customization or add-in solution, Visual Studio will automatically add a reference to the assemblies we need. For example, if we take a look at a document level customization solution, we see the Excel PA. It is given an alias as Excel to make it easier to use. We also see the Office Core PA. The Office Core PA has common functionality that is shared by all the Office applications, including Excel. We don't see the Excel managed VSTO assembly be referenced directly, but it is used in the code that is auto-generated by Visual Studio. If we were to search the She1 object partial class, we can find it. Only we don't need to use the Excel managed assembly directly in a document level solution because it already is a workbook object, and hence we wouldn't need to create one. Obviously, if we wanted to create another workbook object in a document level solution, we can. If we now take a look at a VSTO add-in solution, we can also see the Excel and Office core pairs. We also see the Excel Manage Assembly being referenced directly. For add-ins, it makes sense to reference the Manage Assembly directly since an add-in solution represents the Excel application, and we would need to create workbook objects. In the following videos, we are going to go through some coding examples demonstrating how to use the application Workbook, Worksheet, and Range objects. Here, we have an Excel document level customization solution with basic examples of how to use the application Workbook, Worksheet, and Range objects. In the first half sheet are 3 examples using the application object. The first example shows us how to set and clear a status bar. The second shows how we can recalculate a single sheet or calculate all open workbooks. In the third example, we demonstrate using the worksheet function static object. Worksheet function gives us access to all the Excel functions such as VLOOKUP, SUM, and trim. The second tab sheet has 4 examples on how to use the workbook object. The first shows how to create a new workbook and how to open an existing one. The second example goes over how to get a reference to a workbook object in your code. The third demonstrates saving and closing a workbook. Finally, the fourth goes over how to loop through open workbooks. The third tab sheet covers using the worksheet object. The first example shows how to add a new worksheet object. The second covers getting a reference in your code. The third covers renaming, reordering, and deleting. Finally, the fourth demonstrates looping through worksheets. The fourth tab sheet demonstrates using the range object. In the first example, we go over getting a reference to a range object. Second example covers reading and writing to cells. The third demonstrates looping through cells, and the fourth goes over formatting cells. Let's run the project and see these examples in action. First, let's cover the application examples. In example 1, we add a message to the status bar. The status bar area is at the bottom left around here. When we press the button, it adds the message running process. Then we clear it. The status bar is useful if we want to display a message to users as our code executes. For example, if we have code to generate a report, we can let the user know what step it's in. In general, we use the status bar message to display any information we deem useful. Now, let's take a look at the code. In order to access the application object, we first need to reference the global static object, which is created with very document level customization solution. After we have the global object, we could then reference any of our worksheets or the this workbook object. The this workbook object represents the workbook itself. In this workbook, we have 4 worksheets, and we can get the application from either one. For example, here we select sheet 1, and then we have access to the application object. The best practice is to use the this workbook to get to the application object because it's possible that a worksheet might get deleted and then our code won't work. Scrolling down to the code for updating the status bar, we use the globals object and reference this workbook to get to the application object. From there, we use a status bar property and pass it to string message. To clear it, we pass it a blank string. The second example shows how we can recalculate a sheet or how to recalculate all open workbooks. In cell G13, we have a formula to add cell G11 plus G12. To demonstrate, we set the calculation state to manual and change the value of G11. Now we run the code to recalculate the worksheet. As we can see, the formulas for this sheet were recalculated even though the calculation state is manual. Now we also run the code to recalculate all open workbooks. These are very simple examples, but if we had a more sophisticated workbook, then it might be useful to recalculate formulas. Here is the code to recalculate a sheet. First, we get the calculation state of the workbook and save it to a variable so we could put it back to its original state at the end. Second, we set the calculation state to manual. We then enable calculation to false and then set it back to true. We now call recalculate sheet method to rebuild dependencies. Finally, we set the calculation state back to its original state. The code to rebuild all workbooks is a lot simpler, as all we do is call the calculate full rebuild method. The third application example demonstrates how we can call the built-in Excel functions such as VLOOKUP, left, or trim from our code. To get access to the built-in functions, we use the worksheet function property. For our example, we use a sum function to add 75 plus 35. Looking at the code here, we have the worksheet function property from the application object. It has methods for the various Excel built-in functions. We see the lookup and trim. Here, we use the sum function and we passed it 75 and 35. When using controls such as a button in a document level solution, we get this error message if the zoom level is not 100%. This is a no limitation when working with WinForm controls. The workaround is always keep the zoom level at 100%. We can also set the zoom level from our code. For example, we could set the zoom level to 100% whenever the sheet is activated. Right now, the zoom level is 110%, but if we select a different sheet and come back, it will be set to 100%. Before moving on to the workbook examples, let's highlight a few more helpful properties of the application object. We can use the screen updating property in case we don't want the user to see any screen updating while the code is being executed. To turn it off, we just set it to false, and to turn it back on, we set it to true once our code is done. We can use the memory free property to keep track of the available memory. This can be useful for Excel VSTO solutions that require a lot of memory. We can also control the display settings of our Excel application. For example, we can control showing the scroll bars, formula bars, and workbook tabs. Let's cover the examples using the workbook object. First, we show how to add a new workbook and how to open an existing workbook. If we press the Add Workbook button, we create a new workbook and it shows its name. Pressing the Open Workbook button opens the Workbook Demo 1 file. Going over the code, we see that to create or to open an existing workbook, we use the Workbooks collection from the application object. To create a new one, we just call the Add method. The Add method will return a reference to the newly created workbook. Calling the Open method will open an existing workbook and will return a reference to it. The only required parameter is the file name, including the path. The Open method has optional parameters such as password or to specify open as read only. Before we can perform any operation or automate any workbook, we need to get a reference to it. We just showed how to get a reference to a newly created and to an existing but closed workbook. Now, we are going to go over how to get a reference to a workbook that is currently open in our application. Example to a category has 3 sub-examples. The first one gets a reference to the active workbook. The second one gets a reference by the workbook name. And the third gets a reference by index. The index represents the order a workbook was opened. Looking at the code to get the active workbook, we use the active workbook property from the application object. To get the reference by name, we use the workbooks collection, pass it the name, and then call activate to make it the active workbook. To get by index, we are again using the workbooks collection, but instead pass it an integer representing the order of the workbook. In this example, we get the count of the number of workbooks, and this will give us the index of the last workbook, and then we pass it to the workbooks collection property. These examples here demonstrate how to save as, and how to close a workbook. Let's go over the code. To save, we just call the save method from a workbook object. Here, we get a reference to the active workbook, call save, and then this will save to the last location where it was saved. To save as, we call the save as method, then pass it the path, including the file name where we want to save. We see here that we are saving Workbook Demo 1 as Workbook Demo 2. To close the workbook, we just call the close workbook method. The last workbook example shows how to loop through open workbooks. Pressing the button, it will list out the name of every open workbook. Looking at the code, we see that to loop through open workbooks, we can do for each over the workbooks collection property. In our loop, we aggregate the name of each workbook into a string message. The other way to loop workbooks is by using an index. Here we count the number of open workbooks, then we use a standard for loop routine. The workbooks collection is one index based. The for each way is probably more efficient, but either approach accomplishes the same thing. Here we have examples on how to use the worksheet object. First, we show how to add a new worksheet. If we press the button, we create a new worksheet and it shows its name. Going over the code, we see that we use the worksheets collection from the workbook object. To create a new sheet, we just call the add method. The newly created worksheet will become the active sheet. Example 2 category has 3 sub-examples that show how to get a reference to a worksheet. The first one gets a reference to the active sheet. The second one gets a reference by the name. And the third gets a reference by index. The index represents the order of the worksheets from left to right. Looking at the code, to get the active worksheet, we use the active sheet property from the application object. To get a reference by name, we use the worksheets collection, pass it the name, and then call the activate method to make it the active worksheet. To get by index, we are again using the worksheets collection, but instead pass it an integer. Here we want to reference the first sheet. The third group of examples demonstrate how to rename, reorder, and delete a worksheet. Running the rename code creates a new worksheet, and then I will rename it as new sheet. Pressing reorder will take the new sheet worksheet and will move it as the first tab. Running the delete code will delete the new sheet tab. Turning over to the code, the rename procedure gets a reference to a new sheet by calling the add method and then renames it using the name property. In the reorder code, we get a reference to the new sheet tab and then call the move method. The move method takes either the first parameter or the second parameter, but not both. Both parameters represent a worksheet. We pass a worksheet reference as the first parameter if we want to move before that sheet, or we pass the second parameter if we want to move after that sheet. In this example, we pass a reference to the first tab sheet as the first parameter so it can be moved before it. The delete procedure is straightforward. We get a reference to a worksheet and then we call the delete method. The last example shows how to loop the worksheets. Pressing the button will list out the name of every worksheet. Looking at the code, we see that to loop through worksheets, we can do a for each over the worksheets collection property. In our loop, we aggregate the name of each sheet into a string message. The other way to loop is by using an index. Here, we count the number of sheets, then we use a standard for loop routine. The worksheets collection object is one index based. The for each way is more efficient, but either approach accomplishes the same thing. Let's go over the range object examples. Example group 1 has 3 sub-examples that show how to get a reference to a range. A range object can represent a cell, a row, a column, a selection of cells that contains one or more blocks of cells, which might or might not be contiguous, or even a group of cells on multiple sheets. The first one gets a reference to the active cell. The second one gets a reference by address, and the third gets a reference by R1C1 notation. In R1C1 notation, cell A1 is row 1 and column 1. Cell A2 would be row 2 and column 1, and so on. To get the active cell, we use the active cell property from the application object. to get a reference by cell address, we use a worksheet object and then reference its range property and pass it a cell address. In this case, we pass address A1 to sheet 4. To use R1C1 notation, we use the cells property instead of the range property and pass it an integer for the row and column. In this case, we want A1, so we pass it row 1 and column 1. Here we have examples that go over reading and writing the cells. The first example reads the value hello world from cell G17. The second example sets cell A17 with new value. The third sets the value of contiguous cells I17 through J17, G18, H18 through J18 to 54. Now let's take a look at the code. For the read-write example, we get the reference to G17 and then we get its value using the value to property. In the second example, we get reference to H17 and assign the string new value to its value to property. The third example demonstrates how we can reference contiguous cells with the range property. To pass contiguous cells to a range object, we separate each cell address by a comma. The third example group shows how we can loop through a range object. In the example, we'll list the values for cell G17 through J18. Switching to the code, we first get a range object to G17 through J18, and then we perform a for each over it. We aggregate the address and values of each cell into a string that we show at the end. The fourth group of examples covers formatting cells. The first example formats cell R14 and R16. For cell R14, we make the font bold, italicize it, and set the font to Arial black. We also set the border and the border color. We finally fill in the color for R14. For R16, we set the bottom border and we also apply a number format. The second example demonstrates using a style object to format cell R18. A style object allows us to apply formatting using a template. The way it works is that we first create a style that has the formatting we want, then we apply it to a cell. The benefit is that we can set the properties once and then reuse it as opposed to setting the formatting properties to each cell individually. Let's have a look at the code. In the code for the first example, we get a reference to cell R14, then using the font property, we set the bold, italic, and font name properties. When setting the color for any property, we have the option to use the built-in color index, which ranges from 1 to 56, or use the color property that takes a number as the color, such as from RGB. For example, to set the color for the borders, we use index 4, which is lime green. We could have also set the color for the borders using a color number instead. For the interior, we use an RGB color number. In this case, we use an RGB number object that has parameters 56, 75, and 3, which produces dark green. Here, we set the border style to a continuous line. This code here is to emphasize working with the border property. To demonstrate, we first get a reference to cell R16. To only set one side of the border property, we pass a border index enum to the element operator. There are 8 possible choices. We can set the edges of the border or interior. Here, we only want to set the border line style for the bottom edge and make the line style dashed. Over here, we demonstrate setting the number format property 2000. The other way to set formatting for a cell is by first creating a style object. To create a style object, we call the add method from the styles property. When creating, we give the style a name. We then set the properties for the style, such as making the font bold, font name, and setting the border properties. Then, to apply the style to a cell, we pass a style to the ranges style property. Here, we pass the style to cell R18. We just covered working with the application, workbook, worksheet, and range objects with a document customization level solution. Now, we're going to cover using them with an Excel add-in solution. As discussed before, the code for document level solution is only available when that workbook is open. On the other hand, the code for an add-in solution is available to all workbooks. To demonstrate using the objects in this add-in solution project, we use a ribbon. We won't cover creating and working with a ribbon in this video, as we'll leave that for another video. The ribbon here is organized into 4 groups, one for each object, along with the menus to run the various examples. These are the same examples we demonstrated for a document level customization solution, but instead from an add-in solution. For example, for the application object, we have 3 menus to run the examples. Example 1 menu shows how to set and clear the status bar. Let's run the project and demonstrate the examples. Let's cover the application examples and the code behind it. Let's run a few of the examples, but no need to run them all, as these are the same examples we ran with the document level solution. Most importantly, we will focus on the code. Let's run the process bar examples. The status bar has a running process message, and then we clear it. Now we turn off calculations so we can recalculate the sheet. Now let's move on to reviewing the code. To set the status bar, the code is very similar to a document level solution. Only difference is that we reference this add-in instead of this workbook. So not much of a change. Here we pass a blank string message to clear it. The code to recalculate a sheet is very different, so let's cover it in detail. First, let's review the code to recalculate a sheet for document level solution. In a document level solution, to recalculate a sheet, we first need to get a reference to that sheet. To get a reference, we use the globals object. As we can see here, we reference sheet 1 at every line of the code. Since an add-in applies to the overall application, we need to get a reference to the active sheet. To get the active sheet, we call globals.thisaddin.application.activesheet. But there is an extra step. When working with add-ins, we need to understand the distinction between worksheet and workbook objects from the PIA and one from the VSTO Excel libraries. There is a lot in that statement, so let's unpack this. We discussed earlier in the video that the Excel PIA library is a wrapper over the unmanaged COM interfaces of Office. The VSTO library implements properties and methods that are defined in the PIA library. Going to the top, we have the PIA and the VSTO Excel libraries. We give the PIA an alias of Excel_PIA and the VSTO as Excel_VSTO to make it easier to use them. The PIA has a worksheet object and the VSTO library has a worksheet object. The difference is that the VSTO one has the implementation for some of the properties and methods that are defined in the PS. This means that if we want to use some properties and methods, we want to use the worksheet and workbook objects from the VSTO library. Getting the VSTO worksheet or workbook object is a two-step process. First, we get the PIA object, then we use a helper function to cast it to the VSTO object. The helper function is called getVSTO object, and we get it from the factory property. So right here, we get the active sheet, which is a PIA version. Then we pass it to the getVSTO object helper function, and it returns a VSTO worksheets object. The same would apply if we wanted to get a workbook. The getVSTO object function is overloaded to handle worksheets and workbook objects. After we get our VSTO worksheet object, the rest of the algorithm is the same as the document level version. We get the calculation state of the workbook and save it to a variable so we can put it back to its original state at the end. Second, we set the calculation state to manual. We then set enable calculation to false and then back to true. We now call recalculate sheet method to rebuild dependencies. Finally, we set the calculation state back to its original state. To emphasize the points of the PIA and VSTO versions, let's say if instead we choose to get the PIA active worksheet version. We can see here that if we do, the calculate method would not be available and we will get an error. This means that the calculate method is not implemented in the PIA worksheet object and is only available with the VSTO version. The code to recalculate all workbooks is very similar to the document level solution example. The only difference is that we reference this add-in instead of this workbook. The same for the worksheet function example. Now we look at the workbook examples. Again, they are the same as the document level solution example. Let's run a few of them and then we'll take a look at the code. Let's add a new workbook. And then we open an existing workbook. Also, let's run the save as and looping example. To create a new workbook, we call the add method from the workbooks collection. It returns a PIA workbook. If we need the VSTO version workbook instead, we could also use the getVSTO object method. To open a workbook, we call the open method from the workbooks collection. To get the active workbook, we call the active workbook property from the application object. Here, we also use the getVSTO object method to get a VSTO workbook. Here, to get a workbook by name, we use the workbooks collection. To get by index, we pass an integer instead. To save, we call the save method on the workbook object. This is saving the active workbook. For save as, we call the save as method. Here, we are saving workbook demo 1 as workbook demo 2. To close, we call the close method. For looping through workbooks, we can use the for each on the workbooks collection. Here, we are converting to VSTO workbook. We can also use an index to loop if we want to. Just like our document level solution project, we have examples working with the worksheet object with an add-in. We will run a few of the examples and then we will go over the code. First, let's add a new sheet. We see here a new tab sheet was created. Let's also run the rename and reorder examples. As we can see, a new sheet was created and renamed as new sheet. Then we move it as the first sheet. Finally, let's run the looping examples. Here's the code for our worksheet examples. To get a new sheet, we call the add method on a worksheets collection object. Over here, we get a reference to the active sheet and we convert it to a VSTO worksheet. To get a reference by name, we pass the worksheet name to the worksheets collection object. To get a reference by index, we pass an integer to the worksheets collection. Integer 1 represents the first worksheet from left to right. This code creates a new sheet and then we rename it. Now we reorder the newly created sheet before the application worksheet. This code deletes the worksheet. For looping through sheets, we can use for each on the worksheets collection. This is the other way to loop in case we want to use an index. We have here the same range examples from the document level solution, but instead for our add-in solution project. Let's run a few of them and then we can take a look at the code behind them. This will get a reference to the active cell. Right now, the active cell is C9. Now, let's get a reference to cell C12. Let's also run the read and write examples. We get the value from I9, and then we set the value for I11. We run the loop examples over cell M9 through 12. Finally, let's run the formatting examples on cells R14 and R16. To select the document level example. To get the active cell, we use the active cell property from the application object. To get a reference by cell address, we get a sheet object and then reference its range property and pass it a cell address. Here, we're getting the active sheet as a VSTO worksheet and references the cell address C12. To use R1C1 notation, we use the cells property instead of the range property and pass it an integer for the row and column. We want C15, so we pass it row 15 and column 3. To read a value, we reference the value to property. Here, we are reading value I9 from the active sheet. To set a value, we assign the value to property. The example here sets the value of I9 to new value string. Over here, we are assigning 54 to contiguous cells H14 through I14, comma, H15 through I16, comma, H18. The looping range example is just like the document level example. The only difference being that we get the active sheet as a VSTO worksheet. And the same for the formatting example. Thank you for watching this video from Excel Dev Studio. If you enjoyed it, please give it a thumbs up and subscribe to our channel. This video covered the Excel object model. We discussed how to use the application, workbook, worksheet, and range objects. With this knowledge, you can begin to build Excel solutions. Please make sure to check out video number 4 that covers creating and using the ribbon.